Okay, so recording has started, so I'm sharing my screen. Okay, so we start. So we are going to deal with the real numbers. Okay, you can see my screen now.
Numbers.
Good. So on the real numbers, we have natural numbers. It's okay.
Yeah.
So we have to understand what are natural numbers. So natural numbers are the 1, 2, 3 that we know. Okay. So the 1, 2, 3 that we know, those are the natural numbers. And also we call them positive integers. Okay. So the counting numbers 0, 1, 2, 3, 4, 5. Okay, those are the positive integers. That's another name for it. So one thing about these people is that if you are learning anything, you have to understand. They can just put it that natural numbers are also called what? Because it's MCQ. So the man told you are going to write MCQs, right?
Yeah.
The man told you that your questions will be MCQs.
MCQ. Yeah. So
Uh,
objectives.
yes,
Objectives.
that is objective. It's multiple choice because it's multiple choice. That is MCQ. Okay, because it's
Multiple choice.
a multiple choice.
Okay.
MCQs because it's that they can ask you anything. Okay, so there are some things I will let you note. Yes, when you read, because they expect you to read this. So there are some things I will let you know. Okay, so I will let you note whilst we are doing it so that you will note those things and anytime you ask, you can able to answer them. Okay, so one of them is that natural numbers are also called positive what? Integers. So you
Numbers.
can, yeah, natural numbers are also called positive integers. So you can note that. So I hope you have some small
Okay.
notes with you.
Uh, yeah. Yeah. Yeah.
So they are also known as positive integers.
Okay.
Okay, so that is something I want you to note. Okay, so now that we know that they are also known as this positive integers. Okay, then we can go to the next one. So, here. Okay, then he says, are used in counting numbers of sets. The symbols vary with the times. Example, Romans use, so I are part of the natural number. That is Roman numbers is part. So you should know that Roman numbers is part of natural numbers. Are you okay with that?
Yeah.
Good.
Yeah.
Then it says the sum of A plus B and product of A dot B or AB of any two natural numbers, A and B, is also a natural number. So he's saying that if you add two natural numbers, A plus B, or you multiply two natural numbers, so A dot B simply means you are multiplying, okay?
Okay.
And AB is
Okay.
the same as multiplying. So all that he's trying to say is that if you add natural numbers and or you multiply them, the answer that you get is also a natural number.
Okay.
So anytime you sum two natural numbers. So if he says A and B are natural numbers and you add A plus B to get C, okay? So he's saying that A plus B. So let's say you have A and we have maybe this B. Okay. If you add these two and it give you an answer of maybe C, or what is it? Let me undo.
It seems my screen is a little bit dull, but I don't know whether your place it will be clear. Maybe after getting the record, I will be seeing it clear. The screen
You
is a
can't
little bit
you can't see the numbers well, right?
very good.
Can you able, you can read?
Yeah, it was coming small, but it seems okay.
Is it okay now?
Okay, let's manage it.
I'm coming. Let me expand small.
Okay.
Let me see if I can expand. Can you see it well now?
Okay. Yeah,
This is
very good. It's now
okay.
better.
Okay, good.
This is okay. It's okay.
Okay, good. So let me clear all those things. Okay. Okay, so I'm clearing the red so that you can get.
Okay.
Okay, good. So I was saying that where is the this thing? Okay, good. So I was saying that when you add A to B, okay, you can see now.
Yeah.
And if
Yeah, I can see
this
it.
if this give you an answer of C, okay, because A and B are natural numbers, it means C is also what? A natural number. That is what you want to say.
Oh, okay.
Good. And he's also saying that if you multiply A, so A dot B simply means you are multiply A and B.
Oh, okay.
The dot simply means times.
Thanks.
Okay.
Okay.
Yeah. So if you multiply A dot B, he's saying that if you multiply A dot B and maybe you get D. Oh, it's my network or something. It's not allowing me to write it. And you get maybe D. Okay. He's saying that this thing that you get is also a natural numbers.
Mm-hmm.
Okay. So okay. So A B or A dot B the same. That means you are multiplying. Okay, that is all that is trying to say. So I hope you have kept that in your mind.
Okay.
Through that, maybe you meet some questions, then we use that to answer.
Okay.
Okay. Good. So
Okay.
the next thing we are going to talk about is it says that this is often expressed by saying that the set of natural numbers is closed under the operations of addition and multiplication. So he's saying that the set of natural numbers is closed. So note this word, closed.
Closed.
Yeah, under operations of addition and multiplication, because it's going to be objectives. These are some of the things they will be asking you. So, so the set of natural numbers, those natural numbers or positive integers, they are closed in addition and multiplication.
Multiplication.
Okay. And also they satisfies the closure property with respect to the operations. It is for any natural numbers A, B, C. We have, so he's saying that these are properties of a natural number. And yes, we have A plus B. So the property of a natural number, okay. Okay, let me see. Okay, so here, you can see this one. The one I'm just underline, okay. Is that it's A plus B plus C.
A plus
Equals to A plus B plus C. So you're just saying that if you add A plus B, A plus C in this brackets, and you add the results to A, it is the same as adding A plus B and adding the results to C. If they are natural numbers, that is all that is trying to say.
Okay.
Yeah. So we are just trying to understand some properties of natural numbers before we use it to work.
Okay.
Good. And here he's saying that if there is A plus B, so you have A and B, okay? and you change it. So like he's trying to say that if you have maybe assuming A is 1, so you have 1 and maybe you have plus maybe 2. So assuming B is 2, this is equals to it's the same as 2 plus 1. That is all that he's trying to say.
That's it. Okay.
So no matter how you change them, it's the same. Okay.
See.
Okay. So and the other one is also saying that if you have B plus C into brackets, B plus C, they are inside brackets, okay, and you are whatever product that you get, you add and you multiply by A, this A. It's the same as multiply A by B and multiply A by C. That means expanding the brackets.
Okay.
And so that's what that is trying to say. Then he's calling something an associative property. This one. He says it's called associative property. And he's saying that if you multiply B by C and you multiply the product by A, it's the same as multiplying A by B and multiply the product by C. So if you rearrange those numbers, then he's calling in terms of multiplication, then he's calling them associative property. Yeah, so you should note that because it's MCQ. See, he can just put there A into bracket B, C is equals to A, B into bracket C. What property is that? He can just ask you that. Then you know that is associative property. Yeah. One thing about MCQ is that sometimes things you don't mind, those are the things they ask.
They can ask.
Yeah. Okay. Okay, so now let's go to the other one. So the other one is saying commutative. One is say commutative, all that he meant, or commutativity. Okay. All that he means is that if it's commutative, all that he meant is that if you change, like the way we change the addition, the way we change the addition under this part, okay. When we change the 1 plus 1, we change when we say to change it to maybe 2 plus 2 on the other side, okay. It was the same. So the same to one. So one is multiplying A times B. It's the same as B times A. That is what he meant by commutative. That is why I say it's commutativity. It means whatever you do is the same. Yeah. So we have associativity and we have commutativity. All that you mean is commutative. So if it's commutative, it means that if A times B is the same as B times A. Yeah, it's the same as B times C. That's all that it means. Then, if you have this thing that you just did here, that is said B plus C into bracket A, it's the same as AB plus AC because you have expanded the bracket. He says the name for that. The name for that is called distributive.
Distributive, okay.
It says that the name for that is called distributive. Okay. So now let's go to the next thing. And then go, okay. Good. Okay, good. So introduction to number theory. So we are going to talk about integers. So we have realized that positive integers are also called what? Real numbers. Are you okay now?
Real numbers. Yes.
Or natural numbers.
Natural numbers.
Good. So positive integers are also called natural numbers. So now number theory, we are talking about integers. And it says negative integers and 0 denote by this. So we have negative integers and we also have positive integers. Okay. So it's saying that you have -1, -2, -3. Those are negative integers. That means all that we meant is that, let me show you something. if you draw a number line like this, okay. Oh, why is it that when you draw not on one draw the account? Okay, let me use this one. If you draw a number line like this, okay. So let's say this is a number line. Okay. Then the middle will be what? 0, right? Can you see my number line?
Yeah, I can see it.
Okay, good. I'm saying the middle will be 0, right? So that means this side, if you go this side, that will be what? Negative.
Negative.
And if you go positive side of the 0,
Negative. I think I will right.
So if you go positive side of the 0, that will be what? Positive. The right side of the 0.
Positive.
Okay, let me clear it and do my number line again for you to see it, what I meant. Okay, I said, okay. Okay, so I'm going to do the number line again. Okay.
The place you are, the top line working in.
You said, what's
I
it?
said, where you are, me say, baby, I want a soft line, a yegima. Internet soft line.
Internet.
Makoto be any argument and come with the best. I want to use soft line.
Me soft line there, me checking share. What or a type base, I'm what or a one would the enemy?
A company be almost a soft line. I'm almost 40, 50 gig, but any argument.
Oh, no, send
I don't know.
Yeah, sure, so
Okay.
If I send me.
Okay.
Me sure, so more. Okay. And here another sending me. Why?
Okay. I do my brother. No, taba with the end.
Oh, me quite what is VIP pastor office on.
Okay.
And from a VIP pastor office, now they for me dealing me telephone number and phone. No actual care US na can say you know almost frame it. Omo no mo wa angaga junction ya office or.
Okay.
And yeah, just a stone through. I'll just go and pick.
Okay.
I will cry out Kaya and come and send him out. I mean, say be any panel bantina medium.
Oh, up to now, Sanka.
Okay, I'm coming. Be and VIP pass office and the next day and upon council.
Agabana, and come on the second.
Come back from a bit do you know my fro.
Oh, my friend.
Okay, so young coy anymore. Okay, so he's saying that. And so my number line, say na me patch. Assuming this is a number line, okay. Then the middle here will be what? 0. What you say?
0.
So the middle will be 0. So that means some right side of the number line now, it will be positive. Left side will be negative. How is it? So this side, this one is the negative integers, this part. And this part is the positive integer. Are you okay now?
Yeah, I'm okay.
I'm good. So negative integers and 0 denotes by, so that means 0 respectively and 0 respectively arose to permit solutions to equations such as this, where A and B. So that means 0 no 1 and they determine which is positive and which is negative. Okay, so meaning if you are talking about integers, then 0 is part of it. Are you getting my point?
Yes.
0 is an integer. Okay, but we have 2 types of integer, negative integers and positive what? Integer. Okay, so you say that equations such as this, so x plus b equals to a, where a and b are any natural numbers. So So you know natural numbers are the same as what? Integers.
Positive integers.
Yes, you know them. Good. So if you say there are any
Yeah.
natural numbers, this leads to the operation of a subtraction or inverse of addition. We write x to be equal to. So he's trying to say that if they are natural numbers, then you can factor, you can make s stands. So b can cross equal sign, go and subtract a. So here it's like making x the subject. So he's saying that is possible. You get the point.
Okay.
Good. So now we are going to look at the properties. So let's clear all drawings. Okay. So properties. So let's see. So you say properties of integers. So integers are associative, they are commutative, distributive,
Yeah.
and you add a plus 0, then a plus 0 will be what? A, because 0 is not 0 nyashe. So 0 plus
Exactly.
a is the same thing. Then a times 1 is a, and 1 times a is a. So adding 0 is a, and also multiply by 1 is the same. So what that is trying to tell you is that. Then we have transitivity, meaning a is greater than b, and b is greater than c. But person here, all that is saying here is that because of the property, okay, he's saying at this point, I'm talking about transitivity. Can you see?
Yeah, I've seen it.
Okay, good. He's saying that
A is better.
if you say a is greater than b, and b is also greater than c, obviously a will be greater than c. That is what he meant by transitivity. What you say? Hello?
Yeah.
Good. Okay. Then he says this part is what? Trichotomy or trichotomy. All that you mean is that if A is greater than B and A is less than B, so assuming this A also change B is greater than B and A is less than B, okay, that means A is equals to B. So are you are you getting the idea? Are you getting this part? What he's trying to say? Hello, Amos. Amos, can you hear me?
Yeah, I'm getting it.
Okay, he's trying to say that. Let me clear all so that you can see what is there. He's trying to say that if you this part, he's trying to say that
Yeah.
A can be greater than B, okay,
B
and
and A can be greater
A can also
less
be
than
less than B, and A
B
can also be
or
equals to B.
equals to B.
Yeah, he's saying all
Okay.
those things are possible.
That's okay.
Depending on which number is A and which number is B. That's all that it means. Okay, so that is why it's called trichotomy.
Okay.
That is why
Yeah.
it's called trichotomy.
Trichotomy.
Yeah. Good. So then you come to this, I say cancellations. So
Law.
cancellation law. He's saying that if you multiply A by C and you multiply B by C, okay, if you say A times C is equals to B times C, then C, also that particular C, this C, you know, appear in all the other side, you know.
Yeah.
Also B is only there and A is only there, but what is appearing on the other side is C. So our concern is this C, right? Also, it is here and it is here. Are you getting me? So
Yeah.
because of the it means that if you multiply A by C, assuming C is 0, then the answer here will be what? 0, because if you multiply any number times 0 to be 0, right?
Yeah.
And if you multiply, and if you multiply, oh, let's see. And if you multiply b by 0, assuming c is 0, then that one to the answer will be 0, right? So if you have 0 here and you have 0 here, then 0 is equal to 0. Is that not it?
Yeah.
Okay. So he's saying that if you say c is not equal to 0, then we can assume that if you multiply a by c is the same as multiplying b by c there, then a is actually equals to b. You get the understanding? Because c is not, if c is not 0, it means that what's supposed to be a was replaced here by b. So all that he's trying to say is that, let me give you an example. He's trying to say that if I have 2 times, so in terms of times, I'm using the dot representing times, right?
Dot.
So let's say 2 times 3. Okay. What is the answer?
6.
Okay, so 6. Good. So let's say we are maintaining 3 because that is the C, right? So we have 3 here. Okay. And we are saying this must be equal to that. It means you bring B here. Okay. Then dot. This is equal to 6 because the two are the same, right? If you do this, then B can only be equal to what? 2. You agree?
2. Yeah.
Are you getting what I'm trying to say? If you check what I've done.
Yeah, I'm getting.
Yeah, it means this B can only be equals to 2. Why is it green?
Yeah.
Because 2 times 3 is what? 6. And we have maintained the 3 here, which is the C. Okay. And we have brought B to represent 2. Okay. And we want the answer to be the same because it says they are the same. Is that not it? So you put 6 here. We put 6 here. So if you put 6 here, then the only thing you can multiply 3 by that will give you 6 is what? 2. So that is B is equals to 2. So all that is trying to say is that if that is the case, then A is equals to B. Because we have only replaced A here by B. Are you okay now? You're okay now? Okay, good. So let's go to, so we are treating all those small things, then we tackle questions. Okay. Good. So now let's clear and go. Okay. So rational numbers. Rational, so this is but we are just reminding ourselves. So you remember rational numbers?
A long time.
Yeah, a long time.
Yes.
So we are just reminding ourselves, okay? So okay. So for rational numbers, it's saying that okay, rational numbers are fractions. So rational numbers are actually fractions. Hello?
Yes.
It seems my screen has been just on
Your
share.
screen has come clear.
Yeah, it has just been on share. So let me reshare it. Okay. Okay, good.
Yeah, that's good.
Okay, good. So rational numbers. So rational numbers are simply fractions in this form.
Yes.
Okay. You get the form. So something over something.
Something. 2 over 3.
So good.
That's 2 over 4.
So good. So when we say S is equals to A over B, that is a rational number.
So like like this rational numbers, in case the top one is higher than the down one, it's still it can be a rational number. Like 7, okay, even I can even see 5/4 here.
Yes.
So even if it's 7, and it's still a rational.
Yes.
Okay.
So that is why we have improper fractions and we have proper fractions.
Proper fraction. Okay. Yes. Yes. Yes.
Good. So A is the numerator and B is the denominator. The one dividing. The one dividing.
Yes.
Okay. So the set of integers is a subset of the rational numbers. Since integers correspond to rational numbers, square B is equals to 1. So he's saying that if you make this B equals to 1, then your answer will be just A. Because if one person divide A, he himself gets all the A. Okay. So he's trying to say that integers is a subset of rational numbers. Meaning true rational numbers, you can get integers from them if you divide them by 1.
Okay.
Are you okay now? So let's look at irrational numbers. So we know rational numbers, they are fractions. Okay, A over B. And it became necessary because if you are multiplying something by something and it's equals to A, if you want to find that thing you multiply, then you can only divide A by what? B. That is how rational numbers came to be. Okay. But B must never be equal to 0. Why? Do you know why B must never be equal to 0? This equation, this thing here, condition.
No.
Do you know why?
No.
Because if you divide any number by 0, it will give you undefined. Mass in young fan, mass in Timmy solve.
That problem. Okay.
Nobody knew the answer. 100 million, any pass 0 cha, Obia Benya say.
0.
Because Nipa Nankasa Obuniho. It took us Obia Benya 100 million. Why the nya? Oh, they were sitting. Why the nya? Because Obia knew. And I guess Obia Benya 0 so. I didn't want you on it and 0. You see, so it becomes difficult. It's undefined. That is why anytime they define, they say B should never be equal to 0. So now we are going to irrational numbers.
No.
Yeah. So under irrational numbers, okay. Under irrational numbers, it says when you have root 2, you know, square root of 4 is what?
It's 2.
Good. So that is perfect answer, right? But what is the square root of 2?
2.
Then there will be it will be decimals. So because of that, and you cannot get any fraction for that. Some decimals there. Because of that, it is called irrational number. And a pi, if you divide 27, also pi, I think it's 27 over 7, over what? 7, right? Pi, is it 27 over 7?
Pi is 3.14.
So divide the 27 over 7.
By 7.
Yeah.
Yeah, I know. 27 divided by 7, I'm 3.8. 3.85.
3.85. So 27 divided by 7. What's that I say? 3.85.
3.8.
Okay.
Yeah.
And I'll say pi, so you say
3.14.
3.14. Okay, divide 27 by 9. I'm in shade.
Okay. 27.
That will be 3. Is it
3.
Yeah, that will be 3. So I think there
Yeah.
is pi is 27/7.
Okay.
uh Pi is actually 27/7. Let me check this here.
Okay.
Pi is 3.14. Okay. So assuming we want pi in the fractions, let me see if it's possible on to do it here. So if I want pi, my answer. So answer, I'm doing something, I will just show it to you. Okay. Okay, so this
Okay.
answer.
Okay.
Okay. So pi, because pi 2 is not a perfect figure. Okay, so let's continue. Because pi 2 is not a perfect figure like pi. Okay, that is why that one too. So because of that, they are called also that these numbers are numbers which are not rational. That is, they cannot be expressed as a over b. The
Okay.
closest you can get for pi is 27/7,
Oh, okay.
but that is not actually pi,
Wow.
because 3.14 is not the same as 3.18 or something. Are you getting me?
Yeah.
Good. So such numbers, any number that you cannot really express as a over b, okay, that is an irrational number.
Number.
It means that is an irrational number. Okay, a and b are integers and b is equal to 0. Of course, if b becomes 0, that means undefined, right?
Yes. Yes.
Okay, the set of rational and irrational numbers is called the set of real numbers. So if you want real numbers, it means the set of what? Rational and irrational what? Numbers. So
Number.
that is something you should also note. Real numbers.
Yes.
So real
Real
numbers
numbers.
contains what? R, right? That
Both
is right.
rational and irrational.
Yes. So R plus IR. Are you okay?
Mm-hmm.
Rational and
Yeah.
what? Irrational.
Zero.
Okay. And integers, I, N, whether positive or negative, are subset of what? Rational numbers. Because it could be divided by 1, so it will be the same thing. They are subset of rational numbers. Are you okay now?
Yeah.
Okay. And also the integers, positive integers. Yes, you and I may know. Positive
Yeah.
integers are also referred to as what? And that would be what? Natural numbers.
Natural number. Natural number.
Natural
Yes.
numbers, yeah, natural numbers. So you are okay now. Okay. So
Yeah.
now let's continue. Okay. Okay, so so now principles of mathematical inductions. So the principle of mathematical induction. So he's saying that the principle of mathematical induction is an important property of the positive integers. It is especially useful in proving statements involving all positive integers when it is known, for example, that the statements are varied. So he's saying that there is something called induction, meaning you are coming to make deductions, deduce something
Okay.
to determine if
Yes.
something is
Rational.
valid or not valid. Are you okay?
Yeah.
Okay, good.
Mm.
So let me see. I'm bringing this marker. Okay, so you can say that n is equals to 1, 2, 3, where I've marked green.
Yes.
Okay, so you say, for
Yeah.
example, the statements are varied. For n is equals to 1, 2, 3, but it is
That.
suspected or conjectured that they hold for all positive integers. Then the method
Yes.
of proof consists of the following steps. So he's saying that if n is equals to 1, so all that is saying that n can be 1, n can be 2, n can be 3.
Okay.
Good. So if that is true, then you can say that n is 1. That is some other positive integer. Assume that the statement is true, then n is equals to k, where k is any positive integer. Because 1 is a positive integer, right?
Yeah.
2 is a positive integer. 3 is a positive integer. So if you say n is equals to 1, n is also equals to 2, and n can also be equals to 3, and they are all positive integers, right?
Yeah.
Then one can say that n is equals to k, where k is what? Any positive what? Integer. So that is like making a deduction. Are you getting the understanding? So you are
Yes,
making
yes.
a deduction. That is all that is trying to say. You are making a deduction. Okay. So if that is the case, then he said that if you have n is equals to k plus 1, you see where I've
Yeah.
marked green.
Yes.
Okay. He said that if you have that n is equals to k plus 1,
Plus one.
good. Then this is part of the proof establishing the induction may be difficult or impossible, because you may not know when you add k to it whether it is still going to be a positive integer or not. Why? Because k can be a negative 10.
Okay.
So if k is negative 10, that means your answer will be negative 9. Is that not it?
Yes.
And if your answer becomes negative 9, it means that negative 9 is actually a negative integer but not a positive integer. So once you introduce k to it, then the deduction becomes not possible. So that is why you say it's
Okay.
becoming difficult or impossible. You are getting what she's trying to say.
Mm,
Okay, good. So
yes.
here it says that the statement is true for n equals to 1 from step 1. It must be from step 3, but be true for n equals to 1 plus 1. So he's saying that
Yeah.
if actually k, this k is actually equals to 1, then 1 plus 1 will be equals to what? 2. Is that not it?
Yeah.
Where am I green? And if 1 plus 1 is equals to 2, it means 2 is also a positive integer, right?
Yes.
Good. So it means that uh, you can only say k is any positive integer. Okay. So if you
Yeah.
decide to add 1 to k here, then we can have to know that k must be a positive integer. So that whatever, and we must also add a positive integer to it, then it becomes true. So mathematical the induction is trying to say that before you can make any deductions, you have to check and see if what you are trying to say makes sense according to those things you have just learned, whether they can at the end your results will fall into any of them. What you say?
Uh,
You get that point? Or I should
yes.
go over. Or I should go over.
Oh, it's okay. Yeah.
Okay, good. Okay, good. So now he has some exercises. So maybe that in the book, so that will help us. Okay. So here he's saying that if we check this proof, can we see this proof?
Yes. Proof that 1 plus 2.
Okay. So he's saying that we should prove that 1 plus 2. So you are adding this add to the nth term, meaning there could be 3,
4, 5,
4, it
6.
says, yeah, till.
Yeah.
So the n
Yes.
there could be actually be 100 million. Or it can n can be
Yeah.
just 3. So he's saying that it's up to the nth term. Okay. And he's saying that to determine the next value, you have to actually prove that to determine the next value, okay, is n, the next value, the last value that you have, n is into bracket n plus 1 divided by 2. So it's actually saying that this is n. Okay, this is also n. So whatever you put here will also be n, right? You are getting a point. Hello, Amos. Hello.
Boss.
Okay. Oh, good.
Yes.
So, very good. So, we are saying that 1 is n, 2 is also n, because n, yeah, they are all equals to n. Any of the term is an n. Okay. So it's like n1. It's just like an n1, meaning the first term. Then n2, something like that. Okay. Good. So he's saying that this is n. So assuming we want to determine the first term, n1. Okay. So this is n1. This will be equals to what? This n is what? 1, right? So he's saying it's 1 into brackets n plus, oh, let me undo this. So n, so plus what? 1, right? Into brackets 2. So we know n to be what? 1. So we know the first term. So we want n2. Let me clear these things and do it well. So this is n1, right?
Yeah.
n2, right? So we are looking for, we want to determine n2, this n2, to see. So we are proving the formula. He has given us this formula and want us to prove what? The formula. Okay.
Okay. So wherever you see n, you put 1 there.
Good. So now this is n1 and this is n2. So we want to find n2. Okay, to see if our answer will be 2. Are you okay? So when we come here, so we know wherever we see n, we will put 1 there, like you said. So that will be 1 into brackets. And then we have 1 plus 1 bracket close divided by 2. Okay. So when you add these two, you get a 2, right? 1 plus 1 is 2. Okay. And 2 times 1 is what? 2. So this will give us 2 divided by what? 2. And 2 divided by 2 is what? 1. Okay. So this is this term. So you see that this give us 1. Have you seen it?
Yes.
Good. So when you come to 2, the same thing, if assuming you replace it with 2, let me clear. Assuming you come here and replace it with 2, so to be here will be what? 2, here will be 2, here will be 1, then divided by 2. So this will give us 3, right? 3 times 2 is what? 6.
6 divided by 2.
That will give you what? That will give you what? 3. Okay. So now let's check how he's proving it. So that is the idea. So he said we should prove that formula, okay, to see if that is true. So now let's check. Now that we understand what he meant by that. Okay. Okay. Also, he's saying that n should be equal to 1, 2, and 3, or 4. But it is impossible to verify for all natural numbers on a case-by-case basis. So he's trying to say that if you are going to insert 1 and find out the answer that you will get, and insert 2 and find out the answer that you get, okay, and you insert 4 and find out the answer, so you insert up to 4. He said that it will be impossible to insert all numbers Case square. So go. So when a question like that is given to you to prove, like the way we are inserting one, 2, 3, and the rest. Okay. When something like that is given to you, then he's saying that there's a way we solve it. Okay. We will attempt to show that we can generate the formula for the k plus 1 nth case from this narrative, and the formula is true for. So he's saying that NO is equals to 1 since 1, if you put this one here, this will give you what? The answer will be what? 1. So he's saying that instead of instead of putting numbers that form, if the question like that is given to you, instead of putting numbers through it, maybe you put 1 or put 4, you cannot put all of the whole numbers in the whole word in it. As I was now here, set time no crab everyone. So he's saying instead of doing that, rather think of creating a formula for it and compare your formula to what they have given to you, whether it's the same. So how do you create the formula? Okay, so that is what we are coming to do now. Okay, now let's create the formula. Okay, so he's saying that find the n0 terms. If you put 1 in, okay. So now he wrote this. Then he assumed the value here to be k. Okay. This side, he assumed it to be k. Okay. So the next term, he's saying is k plus 1.
Yeah.
Okay. So
yeah.
He says k plus 1. So because of this, you can clearly see that he's saying this is equals to, this is the formula that was given to us, right? So you're replacing n by k. Have you seen it?
Yeah.
Okay. Then this is k plus 1 because he checked and see that if this is 1 and we are assuming the first term to be k, then if you add 1 to k, you get what? 2. So he's thinking that whatever term you get to can be represented by k. So if you want to get to the next term, just add 1 to that k. You're okay with that? You're okay? Hello? Hello?